my younger brother is right now in high school, and he receives a lot of grades. So here's some examples of the grades he receives. Now, what the teachers do is they don't just calculate the average of the grades. What they do is they take some of the grades and they decide to duplicate them. So, for example, his teachers might decide to duplicate one of the hundreds and a 95. And then what they do is after duplicating, they calculate the average. So they do 100 plus, and then this duplicated 100, and then plus a 90, and the duplicated 95, all over 6. And this average turns out to be 96.66666. What they do then is they give my brother his grades, and then they also give him this average, 96.6. We can call it the duplicated average. And then once they give him this information, that's it. They don't tell him which of the grades they had duplicated. Now, this isn't really a problem for my brother, but it's a problem for actually my mother. My mother has had many instances where teachers have made mistakes when calculating the grades of her children. So she always likes to check the grades and make sure that no mistakes were made during grade calculations. So in this video, let's work on building a program to calculate these duplicated grades. All right, so let's describe the problem a little bit more formally. So what we are given is, a list of n grades, and we're given a average after duplicating some or none of the grades. And this list of n grades, we can just call that grades. And this average after duplicating some or none of the grades, we can call the duplicated average. And we could use dup average for short. And what is our goal? Our goal is to determine which grades were duplicated to calculate the duplicated average. Let's give some examples of input test cases. So you might receive an input where our grades are, for example here, our grades are 100, 190, and 95, and our duplicated average. So teachers, secretly duplicate some or none of the grades and then calculate this duplicated average. Duplicated average is 96.66666. Oh, and one other thing is that this duplicated average is actually rounded to the first decimal place. Something we could add here. So average after duplicating some or none of the grades, rounded to first decimal place. So even if it's 96.666 repeating, it's just rounded to the first decimal place. So in this case, it would be 96.7. And then the output here should be 100 was duplicated and 195 was duplicated. So let's now go about actually solving this problem. So One insight I had was with these grades, you could make a list of only the unique grades, where we just remove all of the, uh, duplicates, copies. Another thing that would be of value is to sort the grades. We could do this. We could say descending unique grades. All right. And so in this case, it would be, now this is great, but these descending unique grades, they don't contain any information about which of the grades did my brother actually receive twice, or 3 times, or 4 times. So we somehow need to capture that information. So what we can do is we can make a dictionary that keeps track of that information. We can call it grade count. This just counts the number of times that my brother received the grade. My brother received 100, received that 2 times. And my brother received a 95, he received that 1 time. And my brother received a 90, and he received that 1 time. Another insight I had was we can actually think of this problem as a tree. So what we can do is we can write all the descending unique grades in order on the left-hand side, and then we could include tree branches for how many grades that my brother actually got. So, for example, my brother got 100 2 times. So what we can do is we can include 3 branches. And what each of the branches indicate is we're considering the possibility that the teacher decided to duplicate none of the hundreds, or decided to duplicate one of the hundreds, or decided to duplicate both of the hundreds. Now, we have the 95. The teacher could have decided to either duplicated the 95 or not duplicated the 95. We can include 2 branches, and we can include 2 branches, and we can include 2 more branches. And then the same thing, the teacher could decide to either duplicate the 90 or not duplicate the 90. So there's kind of 2 possibilities. What we need to do is consider, for this tree, what are we going to store at the nodes of this tree? Well, what we could store at each of the nodes of the tree, and I can illustrate it on the side here, is we want to store the sum of all the grades up to that point. We want to store the number of grades that were used to create that sum. And then we want to also do the average of the grades. So, for example, at this root here, we can call this our root, which is at this point. Well, there were the sum of all the grades, 100 plus 100 plus 90 plus 95 is equal to 385. Nice. And then what was the number of grades that was used to calculate the sum? It was just 4. So we can include that here. And then what's the average? Basically, what is the sum divided by the number? 96.25. Whenever we calculate this average, we always just want to round to the first decimal place. So we can just make this 96.3. what we can do is let's think about, and we can label this as our root, and let's label this node as like A. So what is A? Well, where A is, what we're doing is we're considering the case where the teachers decide to duplicate 2 of the 100s. So what is the sum of taking all the grades and then duplicating 2 of the 100s? Well, what we can do is we can actually take this 385 here, and all we have to do is just add 2 100s. So it's really important here that we're not recalculating the sum. We can actually use the sum that we already calculated. Use it here. So 385 times plus 2 times 100. And then what's the number of numbers that was used to calculate the sum? Well, it's, we had all these grades, and then we decided to duplicate 2 of the 100s. So we had 4 grades, and then we added 2 100s. So it's 6 grades. So again, we're not recalculating it from scratch. We use the fact that we got 4 here, and then just add 2. All right. And another thing is, well, then what's the average that ends up here? So this is something we can easily calculate now. We take the sum and divide by num. And that is equal to 97.5. So in this case, we don't even have to round to the first decimal place because it's already at the first decimal place. And doing that again and again, we eventually will reach these root nodes. The procedure I've shown here is pretty neat procedure, but I was wondering is there a way to make this a little bit faster? Are there any branches that we could, once we get to them, we can decide that we don't need to explore any further? And so there is indeed a case where we can decide that we don't need to prune any further. And it has to do with the fact that we created this list called descending unique grades. So let's say, we get to node C, or let's just call it B. The sum happens to be something, the average has to be something. So our duplicated average is 96.7. And let's say our average right now at node B ends up being something like 93. So the average at B is 93, and what are the next options? So the next options we consider is we're considering, we could consider duplicating a 95, or we consider not duplicating a 95, and then we can consider then duplicating a 90, or not duplicating a 90, duplicating a 90, not duplicating a 90. So just to put all the information into perspective, so B's average is 93. The next possibility is that we're considering duplicating a 95, and our duplicated average is 96.7. So one thing is, because the numbers are descending, so if 95 is our next possibility, then the possibilities after duplicating a 95 are going to be smaller than 95. The next possibility is a 90. Now you can see that we have a 93 right now. If we were to get a 95 or a 90, none of these are going to result in the average becoming 96.7. In order to bring an average of 93 to a 96.7, you're going to have to duplicate one of the grades that is bigger than 96.7. You can think about this intuitively. Like, if you have a 70 average and you desire to have a 80 average, well, what grades are you looking to get? We're not looking to get a 75 or a 78, because while these will raise your average, they're not going to get your grade to the desired average of 80. So we can immediately, you know, uh, stop exploring any sort of children if we see that our grade and our possibilities in the future, specifically just our next possibility, is less than our duplicated average. And so let's say the current average was something like 96, and then our duplicated average is 96.7, then we can immediately say, like, none of these options we don't have to explore.
Hello, everyone. Thank you so much for listening. I took all the ideas that were addressed earlier and actually put them into a Python program. You can use this Python program. Let me show you how it works right now. So this is the Python program. It uses the treelib library in order to create a tree. And here's the main code. The main function is find duplicated grades, where you can put the grades and the duplicated average. And then you could call the function down here. So for example, we have a running example of two 100s, a 90, a 95, and our duplicated average of 96.7. And when we run this, it tells us that one 100 was duplicated and one 95 was duplicated. And in cases like this one, where there are actually multiple possibilities, it'll actually print out all the possibilities. So for example, in this case, we have 100, 190, 180. It could have been the case that nothing was duplicated to get this duplicated average. It could also be the case that 190 was duplicated. It could be the case that 100 and 180 were duplicated, and so on. But thank you so much for watching.